Why do developers keep losing, and how can they stop? Software stability is a critical, yet often untaught skill that determines long-term project success. Think about the hours you've spent fixing code that already worked. From dependency breakages in JavaScript to major framework migrations, this time is often lost to maintaining someone else's decisions instead of building real progress.
Here's something I want you to think about honestly. How many hours have you spent this year alone fixing code that used to work? Not adding features, not improving performance, just restoring functionality that broke because something underneath your project changed without your permission. If you're a JavaScript developer, the answer is probably measured in weeks. If you work with Python and machine learning, it might be months. If you've been through a major framework migration like from Swift UI 3 to 4, React 18 to 19, or the next.js pages to app router transition, it could be closer to a quarter of your working year. Gone. Not to progress, but to maintenance of someone else's decisions. We've been trained to accept this. The industry calls it keeping up. I call it something else. A tax on every developer's time, energy, and career, imposed by organizations that face no consequences for collecting it. This video is about that tax, what causes it, who benefits from it, why we tolerate it, and how to stop. Now let's revisit the dependency cascade problem.
The dependency cascade is a structural defect in modern software. Your code may be fine, but a single update deep in your dependency chain can break your build, even if you've pinned your direct versions.
Let me describe a pattern that almost every developer has lived through. You start a project, you pick a language, a framework, a set of libraries, you build something that works, you ship it. Maybe it's a client project, maybe it's your own product, maybe it's an internal tool your company depends on. 6 months later, you come back to it. You run the build, it fails. Not because your code changed, your code is exactly where you left it. It fails because one of your dependencies released a new version that's incompatible with another dependency, which itself updated to accommodate a third dependency's breaking change. This is what I call the dependency cascade. Your code is fine. The code you depend on broke the code you also depend on. In the JavaScript ecosystem, this is so common, it's practically a rite of passage. The average node.js project pulls in hundreds of packages. Each package has its own dependency tree. A single breaking change at the bottom of that tree can ripple upward and take down projects that never touch the affected code. Python has the same problem with a different flavor. You pin your versions in requirements.txt. You think you're safe. But the libraries you pinned have their own dependencies, and those aren't pinned. A transitive update breaks your environment, and your fixed versions turn out to fix nothing at all. This is not a minor inconvenience. This is a structural defect in how modern software is built, and the cost is enormous, not just in developer hours, but in knowledge, education, and the ability to build anything that lasts. Which brings us to the knowledge destruction problem. Here's an angle that doesn't get enough attention. When a framework introduces breaking changes, it doesn't just break code.
Breaking changes don't just break code, they break knowledge. When frameworks shift, tutorials, forum answers, and courses become liabilities, forcing developers onto a treadmill of constant relearning.
Every tutorial written before the change becomes misleading. Every Stack Overflow answer becomes a trap. Every online course, paid or free, becomes a liability for anyone teaching it and learning it. Think about the scale of that destruction. Thousands of blog posts, hundreds of video courses on Udemy, Coursera, YouTube, books, conference talks. All of it rendered unreliable, not because the information was wrong when it was written, but because the platform it described no longer exists in that form. Swift is a good historical example. When Apple released Swift 2 and then Swift 3 with substantial breaking changes, it didn't just frustrate developers who had to rewrite their apps, it destroyed the entire learning ecosystem that had grown around Swift 2. Developers who had invested months learning the language found their knowledge deprecated overnight. Many left and never came back. the language still hasn't fully recovered its earlier momentum and community enthusiasm.
Swift has struggled to maintain its position among the top programming languages, often slipping out of the top 5 and even failing to capture the enthusiasm it once had.
The Angular major version migrations were even more dramatic, almost turning into a different framework wearing the same name. And the Next.js app router transition created a split where half the tutorials on the internet describe a routing model that's now considered legacy.
Similarly, ASP.NET Core has faced similar criticism for its relentless delivery cycles that have driven away engagement and growth within its developer community, affecting its ability to attract new talent and projects.
Now, multiply this across every framework, every language, every SDK that treats breaking changes as acceptable. The cumulative effect is an industry where knowledge has a half-life of about 18 months. That's not a learning curve. That's a treadmill. So, who benefits from instability? At this point, a reasonable question is,
If instability is so costly, why does it persist?
because it's not costly for everyone.
Often it's a business model based on forced migrations, consulting revenue, and platform lock-in.
When a platform introduces breaking changes, it forces migration. Migration drives adoption of newer services. It creates consulting revenue. Companies literally profit from selling solutions to problems they introduced. It justifies subscription models and managed services. Don't worry about keeping up with changes. Just use our cloud platform. And it builds competitive moats. Smaller teams and independent developers can't absorb the constant churn the way large organizations can.
Some tech giants even benefit from this chaos in several ways.
This isn't a conspiracy theory. It's a business model. And it works precisely because developers have been conditioned to see instability as the price of innovation. But here's what the companies pushing this model didn't account for.
As the SAA Spocalypse proved, this fragility can lead to massive losses when a better option emerges.
The same logic applies to them. In early 2026, the software industry experienced what analysts called the SaaSpocalypse, a rapid collapse in SaaS company valuations that erased somewhere between $1 and $2 trillion in market capitalization within weeks. The trigger was AI agents that could replace entire software workflows, reducing the number of human seats companies needed to pay for. But the deeper cause was fragility. Years of bloated features, broken integrations, forced upgrades, and dependency chaos had left customers frustrated and loosely attached. When a viable alternative appeared, AI tools that cost a fraction of the price and didn't break every quarter, customers left. Fast. Many companies that had profited from instability were destroyed by the same dynamic. Their customers tolerated them only as long as no better option existed. The moment one did, there was no loyalty to fall back on. That's the lesson. Instability is a short-term extraction strategy that always eventually collapses. Whether it takes 5 years or 15, the bill comes due. This brings us to the AI paradox. In December 2025, a critical vulnerability in React server components scored 10 out of 10 on the severity scale, affected 39% of cloud environments at disclosure. Any AI model trained before December 2025 would have generated RSC code with that vulnerability baked in. Not maliciously, just because the model didn't know the world had changed. LLMs like Claude, ChatGPT, and Gemini are genuinely useful for writing code. We use them regularly. But they have a fundamental limitation when it comes to unstable ecosystems. Their training data has a cutoff. When a framework introduces breaking changes after that cutoff, the AI doesn't know. It will confidently suggest code patterns that are outdated, deprecated, or in some cases, insecure. This creates a compounding problem. Developers use AI to move faster. AI generates code based on stale patterns. That code ships to production. The framework updates. The code becomes vulnerable or broken. The developer uses AI to fix it. The AI suggests another stale pattern. The cycle continues. Experienced developers are already warning that AI-generated code from 2025 and 2026 will require significant cleanup in 2027 as teams track down bugs introduced by what's being called vibe coding, generating code through AI prompts without deeply understanding what the AI produced.
AI doesn't solve instability, it amplifies it. If built on unstable foundations, AI can generate code that is deprecated or insecure. Without current knowledge, it ships these errors with full confidence, creating future cleanup tasks.
AI doesn't solve instability. It amplifies whatever foundation it's building on. If the foundation is stable, AI is a force multiplier. If the foundation is unstable, AI multiplies the instability. So, what does the alternative look like? Let me give you a concrete, current example. For over a decade, Python developers lived with pip, a slow, fragile package manager that couldn't reliably resolve dependencies, couldn't manage virtual environments on its own, and required a constellation of supplementary tools just to function. Anaconda tried to solve this by building an entire parallel ecosystem, but it came with its own bloat. 20 gigabytes of disk space for a clean install is common, and its own form of lock-in. In 2024, a company called Astral released UV, a package manager written in Rust that is 10 to 100 times faster than pip. It consolidates pip, virtualenv, piptools, pipx, and pyenv into a single binary. It doesn't require a pre-installed Python interpreter. It uses a global cache, so you're not duplicating packages across every project on your machine. By early 2026, UV is overtaking pip in CI usage for major Python projects. Adoption was explosive, not because of marketing, not because of hype, but because UV solved real, long-standing problems that the community had simply accepted as normal. That's what stability-oriented engineering looks like. It doesn't mean stagnation. UV is a radical improvement, but it's an improvement that respects the existing ecosystem. It works with requirements.txt, it's a drop-in replacement for pip commands, and it doesn't force you to rewrite your projects to adopt it. Compare that to a major framework version that breaks your existing code, invalidates your tests, and forces you to relearn your tools. Both are forms of change. Only one respects the people who depend on it.
The alternative is real. Stability-oriented engineering, like the tool UV for Python, shows that we can solve complex problems properly while respecting existing ecosystems instead of breaking them.
One of the reasons instability persists is that we don't measure it. We measure performance, uptime, test coverage, deployment frequency. We don't measure how often a framework breaks existing code. We don't track how quickly documentation becomes obsolete. We don't quantify the cost of dependency churn. If you can't measure it, you can't compare it. And if you can't compare it, you can't make informed decisions about what to build on. This is why we've been working on what we call the Software Stability Index, an open-source methodology for measuring the impact of software changes on existing implementations.
You cannot choose against instability if you cannot measure it. The Software Stability Index provides an open methodology to track breaking change frequency, documentation persistence, and dependency chain health.
The core metrics are straightforward. Breaking change frequency. How often do updates introduce incompatible changes? Documentation persistence. What percentage of tutorials and guides remain valid after 12 months? Community resource longevity. How quickly do Stack Overflow answers become obsolete for a given framework? Dependency chain stability. How often do transitive dependencies cause project failures? These aren't exotic measurements. They're the questions every developer asks informally before choosing a tool. The difference is turning informal intuition into trackable data that the community can use and contribute to. You can find the SSI repository on GitHub. The link is in the comments. If you've experienced dependency-related project failures, your data points matter. Let me close with what I think developers should take from all of this. Stop treating instability as the cost of doing business. It isn't. It's a cost imposed on you by organizations that benefit from your constant readaptation. You have the right to push back. You have the right to choose tools based on stability rather than hype. You have the right to demand deprecation timelines, migration paths, and backward compatibility from the frameworks you invest your time in learning. Invest in fundamentals over frameworks. Data structures, algorithms, networking, SQL, security principles, system design, these don't deprecate. A developer who deeply understands HTTP doesn't care which JavaScript framework is trending this quarter. A developer who understands relational database design can work with any ORM. The fundamentals are your career insurance against churn. When you evaluate a tool, ask stability questions first. Not what features does it have, but how often does it break existing code? Not how popular is it, but how long do its tutorials stay valid? Not who's using it, but how does it treat the people who already depend on it? And when you find a tool or framework that does prioritize stability, one that ships improvements without destroying what came before, support it, use it, recommend it, write about it. Stability is a feature. Treat it like one. The software industry has spent 2 decades glorifying speed and disruption. The bill for that is now visible in burned-out developers, in trillion-dollar market corrections, in an ecosystem where nothing you build today is guaranteed to work next year. It doesn't have to be this way, but it will stay this way until enough of us decide it shouldn't.
To protect your career, shift your perspective. Stop normalizing rewrites. Prioritize fundamentals over fleeting frameworks. Ask stability questions first, reward stable tools, and measure your dependencies. Treat stability as a core feature. The industry has built its house on sand. By prioritizing solid foundations and measuring what we depend on, we can ensure we are still standing when the next wave hits. Build with stability in mind.
You can find more information about the Software Stability Index under the SSI section on www.techecron.net. I'm Bill, and thank you for watching.